So we shall continue this particular part. So if we come from the yesterday's concept, till here we can continued. So today we shall continue the remaining part of this hydroxylation using peroxy acids. So we shall take the third example as this alkene molecule when subjected with this particular molecule. You may get confused if I use the molecule like this, because people are always for them it will be habit that using MCPBA. This is MCPBA only. This is metachloro perbenzoic acid. MCPBA. So what happens immediately? Epoxidation takes place. Epoxidation means this double bond will be converted to the single bonds between the two oxygen lines. Now, let us take a cis molecule, and you must remember that yesterday we have said note epoxidation is always a syn addition. Means oxygen will add to the alkene molecule from the same side, only one side. So in such cases, if you take the cis alkene, this is cis molecule. So when it is subjected with the MCPBA, you will get only one product. That product is also a meso product. Cis plus cis combination always gives meso. Trans plus trans addition gives meso. Cis plus trans or trans plus cis gives enantiomers. So I will take the trans now. Trans molecule MCPBA. So now you will get the enantiomers. This is one molecule. In another molecule, the compound is like this. They are mirror images to each other. It is enantiomer. These both are enantiomers. So I'll write here. Already had given in our previous classes cis alkene plus cis addition, or else we generally call them as a syn addition. Gives meso compound. Trans alkene plus anti-addition gives a meso compound. Cis alkene plus anti-addition. Both are opposite, no? So you will get the two products. They are enantiomers. And a trans alkene plus a syn addition. Again you will get the enantiomers. So in this way we can solve the questions. So let's try to solve some other questions now. Concept. What happens if this epoxide is subjected with the mineral acid? That mechanism yesterday only discussed. Just to see here, this is the mechanism. Initially, alkene is subject with the peroxy acids and we got the epoxide. When epoxide is added with the mineral acids followed by the hydrolysis, we get the OH groups on the opposite side. So for that molecule, I'll take one or two examples here. So the example is, let's take this is an alkene. Subjected with metachloroperbenzoic acid MCPBA. So we got an epoxide. And it is subjected with the H plus H2. So you will get the glycol part, cyclic glycol. In this, OH groups are oriented in the opposite direction, placed on the opposite direction. So this is the molecule what we call as a trans. Now, just take the trans molecule here, add the MCPBA. This is the step 1 and step 2, H plus and H2. So here you will get the enantiomeric products with the first step. In that enantiomeric products, again if you subject with H plus and H2O, and this is again trans one, no? So trans with the trans you will get the meso compound. So you will get the meso compound. So ultimate product is a meso compound. Hydrogen, hydrogen, or else you can write its equivalent structure in the Fischer projection as CH3, CH3, HOH and HOH. This is a meso compound. So for any doubt clarification, just you revise our stereochemistry part where we had discussed this particular part very clearly. Next, what is meso compound, what is which compounds are meso, which are not meso compounds, and all stereochemistry of these molecules had been discussed. So metachloroperbenzoic acid first step, and the second step is H plus with H2. So in this case you will get the only one product initially. That product undergoes trans addition. So that's why now you are getting the cis plus last step is trans, no? So you will get the enantiomers. First step is syn. First is syn addition, and the second one is, you can check here. Maybe the video is available, yesterday's video, like the live video is available. See, you can see here. It is trans attack. So that's why we are getting the OH groups on the opposite side. So if the alkene is a cis, and the last step, anyhow it is a trans addition, trans attack, means it is actually SN2 reaction. So SN2 attack means opposite side. So what happens here, it is, you will get the enantiomers. So last step we need to consider for the product formation. So these two are enantiomers. So like this we can write down the products, and last reaction in the alkenes molecule, alkenes chapter is insertion of methylene group. This is also very important one. Why? Because to understand molecules and to get the products very easily, we need to follow certain short steps, that is insertion of methylene. So insertion of methylene in this sense, you just take any alkene To that alkene, you add a carbon molecule. Carbon in this sense CH2 is called as CH2 with 2 unpaired electrons is called as the carbon. So when carbon is subjected, then you will get the cyclopropane molecule. Cyclic alkene. To be very frank, it is cyclic alkene. Then how to get this carbon? This carbon can be obtained from different ways. For example, if you take CH2N2, which is called as a diazomethane. When this diazomethane is subjected to the sunlight, it breaks this bond and we get the carbon. And sometimes we take the ketene. Ketene in the sense CH2 double bond C double bond O is called as a ketene, not ketone. So when this ketene is subjected to the sunlight, it also breaks this bond and gives the carbon. And sometimes what we take is we take the CHCl3 chloroform with base. Base means you can take NaOH or else potassium tertiary butoxide CH3 taken thrice CO minus K plus potassium tertiary butoxide. And this particular mechanism actually we shall discuss in the Ramer-Taymer reaction. It forms CCl2 dichlorocarbon. So dichlorocarbon, this is methylene. CH2 part itself is called as a methylene. So this methylene group, whenever added to the alkene part, just like epoxidation, there where we added the oxygen, here we will add the CH2 group. So you just see how is the reaction is. Ethene molecule, CH2N2 and just sunlight. If anybody asks how you will convert this ethylene molecule to cyclopropane, add this reagent. Then you will get this CH2 will go and add here, just like oxygen in the epoxidation. Now you take this one cis molecule and CH2N2 and heat it, or heat or whatever it means, sunlight you can take. So here you will get the cyclopropane molecule, CH3 hydrogen, hydrogen CH3. Now we shall take the trans molecule, trans alkene with CH2N2 and heat it. Now you will get the CH3, hydrogen, hydrogen. Have you seen that here one thing, this is cis, this is trans. Means they maintain their stereochemistry. So CH2N2 do not change the stereochemistry of the basic molecule alkene what we are taking. And second thing is, if you take this is cis molecule or getting cis molecule, trans molecule means trans molecule. These two are stereoisomers. So different geometrical isomers are giving the stereoisomers. Such type of the reactions are called the stereospecific reactions. So stereospecific reactions means the reactions in which two different or two isomers, means geometrical isomers, are giving the stereoisomers. These are isomers only. One is cis, one is trans. So these are called like the stereospecific reactions. Actually, stereospecific reactions definition is a bit different, but anyhow, only for this reaction just maintain this one, because the definition was already given in the stereochemistry. Please see that. If you do not find that definition or if you have any doubt, please WhatsApp me. Do not hesitate. So you take CHCl3, potassium tertiary butoxide, CH3 taken thrice, CO minus K plus, potassium tertiary butoxide. See, whenever you take CHCl3, don't get this CH2 like this. You will get this CCl2, dichlorocarbon. So dichlorocarbon you add here. So CH3 CH, single bond CH, C, Cl, Cl, hydrogen bonds or CH3. So we'll get the molecule like this. And we can add even methylene group to the alkene by using another last reagent, that is here propene molecule. You take this CH2I2 also, but in the presence of the copper and zinc. Here we are not using any light. Light means CH2N2 or CH2CO molecule. Diazomethane, ketene, chloroform, these are different part. Here CH2I2 gives the methylene part only in the presence of the copper and zinc, so that we will get the CH3, CH, CH2 and CH2. And the last reaction, is called as Simmons-Smith reaction.